The rise of artificial intelligence represents the most significant shift in global production systems since the Industrial Revolution, fundamentally altering how we work, manufacture, and consume. This transformation is occurring at breakneck speed across every sector of the economy, creating both tremendous opportunities and complex challenges that society is only beginning to comprehend. As AI systems grow more sophisticated, they are reshaping the very nature of work, while simultaneously unlocking new frontiers in productivity and customization. The implications extend far beyond simple automation, touching every aspect of economic life from factory floors to corporate decision-making to end-user experiences. In manufacturing environments, AI-driven robotics have achieved levels of precision and efficiency that dwarf human capabilities. Systems like NVIDIA's Omniverse platform enable real-time digital simulations of production lines, allowing engineers to optimize workflows before physical implementation. Computer vision algorithms now perform quality control inspections with superhuman accuracy, spotting microscopic defects that would escape even the most attentive human eye. Autonomous mobile robots from companies like Boston Dynamics navigate warehouse spaces with eerie grace, redefining logistics operations. These technologies promise to boost productivity while reducing workplace injuries, but they also threaten to render entire categories of manual labor obsolete. The economic calculus becomes even more complex when considering how these changes ripple through communities historically dependent on manufacturing jobs. The service sector faces equally profound disruptions. Generative AI tools like ChatGPT and Microsoft's Copilot are demonstrating capabilities that challenge the notion of knowledge work as exclusively human domain. Legal firms now employ AI systems that can review thousands of contracts in a time a human lawyer might analyze a dozen. Financial institutions utilize machine learning algorithms that detect complex patterns across markets, making investment decisions in microseconds. Even creative professions are feeling the tremors, with AI demonstrating surprising competency in writing, graphic design, and even musical composition. While these tools can dramatically enhance worker productivity, they also raise difficult questions about the future value of hard-won professional skills and the nature of expertise itself. Perhaps most transformative is AI's impact on supply chain management and production planning. Predictive maintenance systems powered by machine learning can anticipate equipment failures before they occur, reducing downtime by as much as 30% in some implementations. Digital twin technology creates virtual replicas of physical factories, enabling engineers to test countless production scenarios without risking real-world resources. Generative design software explores thousands of potential product configurations, optimizing for factors humans might never consider. These capabilities are revolutionizing industries from automotive manufacturing to pharmaceuticals, creating leaner, more responsive production ecosystems. However, they also concentrate technological advantage in the hands of large corporations that can afford such sophisticated systems, potentially widening the gap between industrial leaders and smaller competitors. The consumer experience is undergoing its own AI-driven metamorphosis. Recommendation algorithms have grown so sophisticated that they now drive a significant portion of e-commerce sales, creating self-reinforcing cycles of preference and prediction. In healthcare, AI systems analyze medical imaging with accuracy rivaling seasoned radiologists, while personalized treatment algorithms suggest therapies tailored to patients' unique genetic profiles. Even mundane retail interactions are being transformed by facial recognition and predictive analytics that attempt to anticipate customer needs before they're voiced. This hyper-personalization creates remarkable convenience, but also raises profound privacy concerns and questions about algorithmic fairness. There's growing evidence that poorly designed AI systems can perpetuate or even amplify existing biases, whether in loan approval processes, hiring decisions, or law enforcement applications. The workforce implications of these changes are particularly complex. While AI undoubtedly eliminates certain jobs, it also creates new categories of employment that demand different skill sets. Roles like AI trainers, data ethicists, and machine learning operations specialists barely existed a decade ago, but now command premium salaries. The challenge lies in ensuring that displaced workers can transition into these new opportunities, which often require technical competencies that traditional education systems struggle to provide. This skills gap threatens to exacerbate existing economic inequalities, potentially creating a bifurcated labor market where those with AI literacy thrive while others face diminishing prospects. Ethical considerations loom equally large. The concentration of AI development in a handful of tech giants raises concerns about corporate control over foundational technologies. The environmental impact of energy-intensive AI systems conflicts with sustainability goals. Perhaps most troubling is the potential for AI to be weaponized, whether through autonomous military systems, hyper-targeted disinformation campaigns, or algorithmic manipulation of financial markets. These dangers have prompted calls for regulatory frameworks, but the pace of technological advancement consistently outstrips the ability of policymakers to respond. Looking ahead, the most successful organizations will likely be those that view AI not as a simple tool for cost-cutting, but as a catalyst for reinventing business models and creating new value. This requires substantial investment in both technology and human capital, as well as a willingness to rethink long-standing operational assumptions. Workers, for their part, must embrace continuous learning as a career-long imperative rather than a one-time educational experience. Governments face the delicate task of fostering innovation while protecting citizens from potential harms, a balance that has eluded many nations thus far. The AI revolution presents society with a paradox. Technologies that promise to solve some of humanity's most persistent challenges also threaten to create new problems of comparable scale. How we navigate this transition will shape the economic landscape for generations to come. There is still time to steer these developments to a broadly shared prosperity, but doing so will require unprecedented cooperation between technologists, business leaders, policymakers, and civil society. The alternative, a future where AI's benefits accrue to a privileged few while its costs are borne by the many, is too grim to contemplate. As artificial intelligence continues its relentless integration into global production systems, we are witnessing the emergence of secondary and tertiary effects that extend far beyond initial automation capabilities. The technology is now entering a phase of recursive self-improvement where AI systems are increasingly being used to design better AI systems, creating an acceleration loop that even experts struggle to predict. This phenomenon is particularly evident in semiconductor manufacturing, where companies like ASML are using AI to optimize extreme ultraviolet lithography machines, the very equipment needed to produce next-generation AI chips. The implications are profound. We're approaching a point where technological advancement may no longer follow linear human timelines, but instead progress at a pace dictated by machine learning algorithms themselves. The nature of work is undergoing a parallel transformation that goes beyond simple job replacement. We're seeing the rise of hybrid intelligence, workplaces where humans and AI systems collaborate in fundamentally new ways. In fields ranging from medical diagnosis to architectural design, professionals now interact with AI assistants that serve as both tools and colleagues. Radiologists work alongside image recognition systems that highlight potential anomalies, while architects use generative design platforms that propose structural solutions, balancing aesthetics, functionality, and sustainability. This collaboration is creating new forms of expertise, what MIT researchers call centaur skills, the ability to effectively partner with AI systems by understanding their strengths and compensating for their weaknesses. However, this new paradigm also demands continuous adaptation from workers, as the division of labor between human and machine evolves unpredictably. At the macroeconomic level, AI is reshaping competitive dynamics in unexpected ways. The technology is acting as both a disruptor and an equalizer. While large tech firms dominate AI development, cloud computing platforms are democratizing access to powerful tools. A small manufacturer in Vietnam can now lease sophisticated quality control algorithms via AWS that would have required millions in capital investment just 5 years ago. Simultaneously, AI is enabling mass customization at scale, allowing companies to profitably produce batches as small as 1 unit. This shift threatens traditional economies of scale advantages, potentially redistributing competitive power across global supply chains. The geopolitical implications are significant as nations race to establish AI supremacy not just in consumer applications, but in core industrial capabilities. The environmental dimension of AI's impact on production presents another complex trade-off. On one hand, AI optimization is reducing waste in manufacturing, improving energy efficiency in data centers, and enabling more sustainable logistics networks. Google's use of DeepMind to reduce cooling energy consumption in its data centers by 40% demonstrates this potential. Yet the environmental cost of training large AI models, with some estimates suggesting GPT-3's training emitted as much carbon as 120 cars would in a year, reveal a troubling paradox. The technology that helps solve sustainability challenges may itself become a significant contributor to climate change unless new approaches to efficient computing are developed. Perhaps most intriguing is AI's growing role in research and development itself. Pharmaceutical companies are now using generative AI to propose novel molecular structures for drug development, dramatically compressing discovery timelines. In materials science, machine learning algorithms are predicting properties of hypothetical alloys and composites before they're physically synthesized. This AI-driven discovery engine could potentially accelerate innovation across every scientific and engineering discipline. But it also raises philosophical questions about the nature of invention and intellectual property. When a patentable discovery emerges from an AI system's probabilistic calculations rather than human intuition, how should credit and ownership be allocated? The social contract between businesses and workers is being rewritten in real time. Traditional models of employment, compensation, and career progression are being challenged by AI-enabled productivity gains that disproportionately benefit capital over labor. Some forward-thinking organizations are experimenting with novel arrangements like productivity profit sharing, where workers receive direct compensation from efficiency gains generated by AI tools they help train and implement. Other companies are establishing automation dividends that partially redistribute cost savings from AI adoption to displaced workers. While still nascent, these approaches suggest potential pathways to more equitable distribution of AI's economic benefits. As we stand at this inflection point, it becomes clear that managing AI's impact on production requires more than technological solutions. It demands new economic models, updated regulatory frameworks, and reinvented educational systems. The choices we make in the coming years will determine whether AI serves as a tool for broad-based prosperity or becomes an engine of inequality and instability. The challenge is as much about human values and social organization as it is about bits and algorithms. The AI revolution in production is unfolding daily with new developments that could reshape our world. If you're fascinated by these transformations, help build our community of forward thinkers. Your likes make this content more visible to others who should be part of this discussion. Share this video with colleagues who are navigating these changes in their industries. Subscribe to stay updated as we explore both the promises and perils of AI in our economy. In the comments, share your experiences. How is AI already changing your workplace or industry in ways that might surprise others?